Welcome back. This is the second lesson recording for IM1 of September 9th, 2020. So up to now, we've had some practice with describing a situation using a graph and using the function notation. So we saw the example of water jug, the volume of the water against as a function of time. Okay, this time we're going to investigate another situation where a dog is going away to fetch a ball, and it is going to be a function of distance away from the camera as a function of time against time. Okay, so they are going to see how far the dog is at different points of the time. So we're going to watch the video together first time. Okay, so it's going to be input is time and the output is distance from the camera. So it's going to be distance versus time graph. Okay, and he is staying put until about 4 seconds, and then he starts running, finds the ball, and then starts running back. There we go. Okay, all right, so here it is. So there is a distance against time. There is this, that's the graph. And now we're going to replay it slow motion, or at least half time. Okay, at 4 seconds he starts running. Before 4 seconds he was right at the camera. Okay, and then he is slowing down a little bit, and then he is found the ball, and now he is coming back towards the camera. So the distance from the camera is actually decreasing now, right? Okay. All right, so at this point, I want you to open up the second card of Desmos and do your best to see if you can graph the situation yourself, okay? Can you graph that right now? And I am going to assume that you have done so, and I'm going to play the rest, okay? And it's perfectly okay if your graph is not quite accurate, because I am going to reveal the graph for you. But I do not want you to change it. I just want you to leave it as it is, but you've thought about it. That's the important part. Okay, and now they're going to graph it. Look at what happens at 4 seconds. He's going. A little after 4 seconds, and he's going away, and slows down and fetches the ball, and then starts coming back. So the distance is decreasing there. Okay. All right. So now what you're going to do is you're going to go through the rest of the questions from Desmos and answer those questions to the best of your ability. And when you return, we are going to go through the answers together. Okay, I am going to ask you to pause the video and go through the Desmos exercises, and then let's go through the answers now. Okay, so what is happening is this is a graph of dog's distance away from camera as a function of time. Okay, so it's the distance is the output, distance from the camera is the output, and the time is the input. So the input is the time, which is the independent variable, and the distance is the output, which is the dependent variable. It depends on the time. That's what it means. Okay, and this is the graph that they gave us, right? And I hope your graph was somewhat similar. At least you're starting to understand how the graph is made, okay, or what different points on the graph really means. So then you are asked to figure out what D of 13 is. What is D of 13? It's really asking where the dog is at 13 seconds starting from the time they started to film. So D of 13, at 13 seconds, the input is 13, and we're looking for the output. At 13 seconds, we go up from here, and we see the graph is crossing right here, and then we go across, and it's about 10 feet. So at 13 seconds, the dog is about 10 feet away from the camera. That's what we are told. What about D of 2? What is D of 2 asking? it's asking where is the dog at 2 seconds of starting to film. So after 2 seconds, after 2 seconds is here. Where is he? The distance from the camera is at 0. That means he's still staying put. He hasn't been released, or the ball hasn't been thrown yet. Okay. All right. Then the next slide. The next card was asking when what is the t when d of t is 20? What is this really asking? It's asking asking for the time when the dog is 20 feet from the camera. When the dog was 20 feet away from the camera, that's 20 feet from the camera is right here. You look for the graph, and how long since the start of the filming? It's at 6 seconds. So we can say time was at 6 seconds. Is that the only answer? No, because if you keep going, the dog, Figaro, is at the same place on his way back. So the first time was when he was going out to fetch the dog, but as he was returning, he was 20 feet away from the camera, right there as well. Okay, so that is about 11.5 seconds. So at 2 different places, the Figaro was 20 feet from the camera. Okay, so at this point, you are going to be working with your teammates on a Jamboard. And so it's going to be function situation with team support. It is going to be the Jamboard that I am going to put the link in the camera, okay. It is going to look like this. Okay, so what you're doing, if you are doing this by yourself, then you're going to have to do this on your own. You're going to have to make a copy of this, and since you're not working with a team, you're just going to do it by yourself. Okay, and if you go to the next slide, it gives you explanation of the function of P of T, gives the number of people, millions who own the smartphone, and so on. It asks you all the questions. You're going to find the link to this in Canvas, so please go ahead and complete this as well. Okay. All right, and then finally, what do we do afterwards? This is just some explanation of all the things that they were supposed to have done. Closure, you were supposed to write entry on the table of content in notebook, and saying that today's day using function notation in situation and graph. And also, I would like you to fill out the last card on the Desmos, which tells you how was your group activity experience today. Okay, was that productive? Was it sort of waste of time? Do you have any suggestions to make it a little bit more productive or a little bit more active or whatever else? Did everybody have their camera on? Were the people contributing? So on and so forth. Okay, that's it for today. So I hope you are able to catch up. Thank you.